So welcome back to the second phase of balancing redox reaction, but in this case in the alkaline solution. Now the question says write a balanced ionic equation for the redox reaction between tetraosomanganate 7 ion and hydrazine, that's N2H4, in alkaline solution. Now, like I said, the first step is you identify the first half of the equation. The first half of the equation. So step 1, you write the first half, manganate MnO4, manganate ion. Now in this situation, manganate is reduced to MnO2 because there is incomplete ionization here. This is the basic medium. Oxidation. While hydrazine N2H4 is oxidized, reduced to nitrogen gas. That's step 1. So having gotten the step 1 done, you move to step 2. Now, just like we explained in the acidic medium between iron and permanganate, here we look at what we have. Now, mind you, we have 4 oxygen here, but 2 of the oxygen was used up with hydrazine. So this 2 is what is left. So therefore in step 2 we are having MnO4. Here we'll be adding, this is the basic medium now. So we'll be adding water and hydrozonium ion, that is the hydroxyl ion, OH, because it is a reverse of acid base. So we'll be adding water first. Now here, how much water will be produced? Remember, 2 oxygen has been used up, so we have 2 oxygen left, which will produce 2 molecules of water, 2H2O. So having done that, we look out for the ion. We'll balance the ion. Here we have, what are they reducing to? MnO2 plus MnO2. Here we'll be adding the hydroxyl ion. So how much of hydroxyl ion are we going to be adding? Of course, from here we have 4, and from hydrazine we have 4 hydrogen. So we have 4 molecules of hydrogen ion. Hydrozonium ion. Yeah, that's what we are having. Then we balance the ion to see how much deficiency. Now in this case, wherever the deficiency ion is where we are writing it, because we might not be getting the same as the acidic. Now here we have plus 1 electron. This is 1 ion. Nothing is here. Here we have 4 ion by the virtue of this coefficients. So this is 3 deficient. So we have 3 electron. We add it here. That's for the phase 1. Now let's come to hydrazine. We have N2H4. N2H4 plus, we are adding OH now. How much? Hydroxyl ion. From the formula we have 4 hydrogen. Automatically we can produce 4 hydrozonium ion, 4 OH. And then that gives us, hydrazine is reduced to N2. So we continue from what we have, N2 plus, so how much of water are we adding? How much water are we adding? If you check out the balance, the equation to balance, so we have 2, 4 hydrogen is produced already. So we have 4 plus 4 hydrogen, that's 8 hydrogen. Then 4 oxygen will give us 4 molecules of water. That is 4H2O. 4H2O. Now balancing up the ion. You always remember that is the essence of this redox reaction. The ion, the ionic equation has to be balanced. So we have 4 ion here, while nothing is here. So we have 4 deficiencies here. We are adding 4 electrons here plus 4 electrons, and that gives us a balanced 2 halves equation. Now considering the overall, we are looking at the overall. Just like the principle, we write everything on the left hand side and equate to everything on the right hand side. Then we'll balance up again. Let's now see what we have here. On the right hand side we have MnO4 ion plus 2H2O plus N2H4 plus 4OH hydroxide ion, then plus the 3 electron to produce then the second half MnO2 plus N2 here, then plus 4OH plus 4H2O plus 4 electrons. Now let's now count and see how balanced our equation is. Manganese 1, oxygen is 4 here plus 2, this is 6 plus 4, oxygen is 10. Let's find out here. 2 oxygen here, 4 oxygen here, that's 6 plus 4 oxygen here, 10. Oxygen is balanced out. Now manganese is also balanced out. Hydrogen, now let's come to hydrogen. We have 4 here, 2 times 2 4 plus another 4 8 plus another 4 here from this coefficient, that's 12 hydrogen. Now let's see here, we have 4 here, 4 times 2 8, 4 plus 8, that's 12. Hydrogen is also balanced out. Now come to nitrogen. We have N2. Nitrogen is balanced out. So we have every element balanced out. Now let's come to the ion. Now here we have 1 ion, 1 plus, we have 4 ion here by this coefficient plus 4 plus the 3 electron that was added up, that's 3. So then let's now equate to, here we have 4 ion plus 4 adding up, that's 4 plus 4, 8. So we have the ions also balanced. So this is the A and Z of balancing redox reaction. Stay tuned for the next topic I'll be looking at, especially for the JUPEP and JAM students. We'll be looking at hybridization and how you pack naming in organic compounds or of organic compounds. Stay tuned. Please like, subscribe, and share. Thank you.